Assalamu alaikum. My name is Nazim Shabal, and today we will discuss about our Rapper Weather report as our semester project of MES microcontroller and embedded system. So this will work as a report that will follow a line and go to the points that are check marked as table 1, table 2, table 3, and table 4. So these are our checkpoints where the report go, and it will detect the table number from the ESP cam and the A model tape in it, and it and we send the instruction from the our IoT platform, from where it will get the instruction to which table it want to go. So if we send it table 1, it will go to the table 1 and stop at table 1 and then return from it. So this is the schematic diagram of wrapper, our wrapper report. So the things we are used, our the main master board is ESP32, ESP32. This is 38. This is our main master board, and this is the Arduino Nano, which we are used as a processing board, and ESP cam, which will handle the A model and send the instruction to the ESP32. So this is our Arduino Nano. We are using IR array with it, IR array with it, the motor driver, ultrasonic sensor, and extra things are servo and color sensors. So this is our Arduino processing. We are using that IR array will detect the line and track the line. The motor driver will make its function, and the obstacle sensor will sense that is there any obstacle in the way or not. So this is the main function of our Arduino Nano. So the other extra things are color sensor and servo. Servo is for the motion of obstacle over there sensor, and color sensor are for detecting the color. So these are not necessary things, and the ESP cam and the ESP32, sorry, ESP32 will handle mainly the reading units of our system. So reading units are current sensor, voltage sensor, MPU. MPU we are using in the IMU model MPU 6050, and OLED SD card, and encoders of the motors. So we are using encoder motor, built-in magnetic encoder motors. So there are tokens of each motor in it. So there is our SD card. There is a writing from master slave and master input and write and output, right? So this is clock pins and these are pins. So our OLED is working on I2C bus, ST and SCL pins. This is our MPU working on the same formula like the OLED and as I2C bus, SCL and STA. And these are independent voltage and current sensors which gives the analog outputs which are connected like this. This is our main power line from where the power will come. We have three sections in it. So we are mainly using ground and 7.4 volt in it. We are not using 3.7 and 11.1 volt. So this is our ASP cam and cam area. I have left the spare extra pins of ESP32 in it, but these are useful in other projects, not in this. And this is our main pins that we are using in ESP cam: 5 volt, 3.3 ground, and TXRF for the cam. So next we're moving to the PCB. So this is our PCB layout. This is a complete board completed with the motors mounted on the PCB. So this is the sensor placement. This is our IR array, our obstacle color sensor, servo, OLED, and SD card module, MPU. This is the Arduino Nano. This is voltage sensor, the voltage sensor checkpoint, our LT98, the power rail. This is all the two resistor which we are using to convert the Arduino 5.5 volt logic to the 3.3 volt logic to save our microcontroller, because the ESP32 works on the 5 volt logic. ESP32 works on the 3.3 volt logic, and our Arduino work on the 5 volt logic. So if the TX of the 5 volt TX of the Arduino Nano gives a 5 volt to the RX of ESP32. Our ESP32 will be burned off. So that's why it is important. We are using a VDR in it of R1 as 1K and R2 as 2K. So this is our complete circuit, and moving towards our Java is not available. We are moving to our 3D view. So this is our 3D view. In this there is no in this laptop there is no files of Arduino Nano and Arduino ESP32. Sorry, ESP32 is available. So these are coming empty. So we'll leave this space as I have added obstacle avoider and color system, blah blah blah, these things that I have mentioned before. And this is our bill of materials that we have which we have priced not mentioned, but we have mentioned the names, the things that are using it. So that is the complete from my side, and the other things should be explained by my classmates, by my teammates.
Hi, as we discussed that today we are discussing about the Vader LFR robot. In this video, we are going to cover different points. One is the complete working and process of the project, that how will it work. Then we are going to give you a final working demonstration of the video, and then the final hardware setup. Before, we already discussed with you the PCB design and its implementation. So the PCB design and its implementation, as you can see here, is already done. Based on this design, that why we chose this design or why we chose these microcontrollers, we could have used a complete microcontroller, but that would have led to um, hassle, or you can say that we wouldn't be able to check it in process or steps. So it is easier to start with the step-by-step microcontroller process. As we already it's mentioned that we used Arduino Nano, in order to control the main sensors, which is IR, ultrasonic sensor, and the motor control as well. So based on that, our LFR was running. But in order to optimize the LFR further and for it to reach to its optimal point or the table to which it is going to be designated, we had used different sensors. A few of those sensors are MPU sensor. Then we have the encoders. Both of these are coordinating with each other in order to sense the position, the speed of the LFR Vita robot. So whenever it moves on the line, if there is a sharp turn or if there is a slow turn, based on that, the speed of the motor will adjust itself. One of the major part of this project was AI intelligence using the CAM system. Now, if we are going to use the CAM system, we were designated to detect four numbers: one, two, three, and 4. In order to detect those four numbers, we need to train the model based on the number we are taking: one, 2, 3, and 4. Now, we will discuss how we trained this overall model. Before discussing that, let's talk about the working of this project. So what happens is that, first of all, the first layer, the major layer that we have is Arduino Nano, which is going to sense the line. And after the line is sensed, we are going to see if it is on the black line. If the sensor is on the black line, it will both of the motor will work and it will go straight. If it is going to take the right turn, one of the motor will slow down and it will take the right turn. Now the turns are of different kind. One can be sharp or it can be a mellow turn. So based on that, the encoder and MPU sensor will help adjust its speed. After that, these two sensors, the sensors that we are talking about, are basically integrated with the ESP32. This ESP32 is responsible for all the sensors that we have here: encoder, MPU, OLED, current and voltage sensor. So these are controlled by this. After that, the third MCU, or you can say camera, we used is ESP cam. Using the ESP cam, we are detecting the obstacle 1, 2, 3, and 4, which is basically more like the table 1, table 2, table 3, and 4. So, if uh, the robot is asked to go to table A or table 1, table 2, 3, 4, it will perform a certain gesture, or it may perform a forward or reverse motion depending on what the program is done. Currently, we did the motor programming just random that just the motor works. We didn't program it on logic for now. We were mainly focusing on the AI part of the camera component. For the AI part of the camera component, we used the edge impulse model. The edge impulse model is basically where you train your AI model based on the pictures. Now, first of all, I will share that this is how we made the code. This was the last code that we did was, I think, this one. Okay, so before we get to write the code, we need different pictures. I will show you the pictures here. So we took the one, two, three, four. I wrote them by myself. So they are custom made and don't match anywhere else. And after writing them, I used the ESP cam to take different pictures. As you can see, there are many pictures of four. Then there will be pictures of one, then there are pictures of four again, two, three, and so on. These pictures are taken so that our model can know that these are the pictures that they need to detect, and we can label these images as three, one, two, four. So whenever your cam detects that number or you bring that number in front of it, what happens is that it detects that number. Sometimes we notice a latency or delay because of the microcontroller speed, or maybe the system that you are using is not providing voltage properly or current properly. Because of that, we may experience some lag, but after that, it will reset and it will show the number that you are basically displaying in front of it. In order to control that latency, we can improve the code, but this was the beginner, so we mainly focused on proper detection. So these pictures were uploaded on the Edge Impulse. After that, we created an impulse. We trained the model based on the numbers that we have, and then we uploaded the code on Arduino IDE. This code was then compiled into the microcontroller ESP cam. We had saved these pictures on the SD card as well initially, so that we have the data saved in the memory as well. Okay, this one might take time. While we are at it, let's look at the system as well so we can have a better understanding about the system that we talked about and the final working of the system, uh, which we are talking about with AI. So, this is an overview. In the end, I will show you the final system with. Okay, so let's go to the download section. And this is the AI cam. This is not the full logic, but this is the how the AI cam will detect. This is how we initially, these are the initial codes of it. So this is the first video. It might take a little while. So while it is uploading, this is going to tell us at what number the camera is on. And if there is no number on the camera, what will the camera do? It's still loading. Okay, it has opened up. Okay. So this is what we did is that we pointed it on 4, and it should show the 4 value here. The screen is blurry, but it is actually showing you the 4 number. This hassle cannot be done on hardware. You can only test it on the software part. So whenever we check the 4, now right now there will be no number, so it shows that no number is detected. You can see that only one line appears here. It indicates that no number is detected. But if we bring 4 again, you can see there is just one line indicating that no number is being detected here. So this is basically how our cam works. This is a serial monitor on which we are basically monitoring the kind of number that is being displayed. Originally, what we did was that we trained one sample on number 4, another sample on number 3, then another sample on number 2, and after that we trained a sample on number 1, so that we have optimal sample for all of them. There were about 30 to 25 pictures for each of them. Then we uploaded them together, and then we decided a code. We also tried to merge the code, but the one that worked the best was when we together put the pictures, labeled them, applied the area or the shape detection feature, which basically colors this four part. All the part that you are seeing colored, it gets colored in that feature, and after it gets colored, it is more easily detected as compared to a scare based detection. Okay, so this was how Edge Impulse is working. But how did we integrate it in the hardware? Let's close this one. And so this is the hardware part where we are showing the number that is being detected. Okay, let me wait. So what you can see here is the OLED that we connected here, and then we have had the numbers here. We brought the numbers in front of it, and based on the number that is there, this one shows or clicks on that number just to show that this table is being clicked. Because we couldn't integrate motor properly, we had to somehow show that the camera is detecting the accurate number, and that is how we did it. Now I am replaying the video, and meanwhile I will interpret the changes for you. So now we applied 4. Now when we apply 4, this is 4, 3, 2, 1. So 4 will be clicked. Oh, now you can see this 4 will be clicked. Now we will change it to number 2 probably. The flash is basically, it is taking the pictures and it is re-uploading or rematching it with the data it has been provided with. Now 3, so it will light up the third number. Okay, it light up the two number because previously we did the second number. As I told you that there is latency, there is delay when you are applying it with so many appliances, and our focus was on proper detection of the number, not on the working or proper. You can say the prop. It wasn't on the optimization of the code, but basically proper detection. Okay, moving onward. Now it will detect the three number after the latency is gone. Yeah. So now it will detect number 1, just like that. This was how we detected the numbers using the AI cam module. There are other ways as well, but this is how we did it. Okay, now this is basically the IR sensor, the obstacle avoider sensor, and the MPU sensor. Now, based on, we didn't upload it on the track, but the video that we could show so that you can see how the logic was working for the ESP32. We also gave it to the 5 volt in case there is any jittering of the sensor. So to avoid that, we just added a 5 volt instead of the lining itself. Okay, I'm playing the video so you can see the logic for yourself as well. Okay, so I'm playing the video now. Okay, so now when we place the hands here, based on that, the sensor is lighting up. After all, it will stop. We couldn't show you the motor working because we were more focused on the working of it. You can see the motors are moving based on the. This one is slow and this one is faster. So this is the overall working of our project. Anything that we are missing would be, yeah, one important thing that, although it would have been mentioned, but it's important that we are using Arduino Nano and ESP32. Arduino Nano gives output as 5 volt and ESP accepts 3.3 volt. Now, if it is accepting 3.3 volt, 5 and 3.3 volt is a big mismatch. In order to manage that, we actually use the resistors. Now we have covered the working of the project, demonstration of the whole working system, final hardware setup as well, that is shown to you, and PCB design and implementation. Probably the PCB design is shown to you, that we also use the logos as well in the top silk, and we got it fabricated as well along with the PTH or path through hole. So after this, we are going to upload a video which will show you the proper working, or you can say an integrated or one whole system, or where how the hardware actually work. That will give you the more idea. Now, anything that is left would be nothing. That is all for now. In the end, we only have the hardware, so we will share the video in the end. Stay tuned. Thank you so much.